sometimes good to understand what's happening behind the scenes, the stuff you don't see, to understand coding a little bit better. We talked previously that when we have a variable such as campus and we assign a value to it, such as South Mountain, that is stored in memory. We don't see that happening. And we also know from our CS 105 that everything the computer sees is zeros and ones. So every letter is made up of a combination of zeros and ones. And so in RAM, what we're having stored is a whole bunch of zeros and ones. Let's get even a little more technical here, and that is in English, we typically are using characters that are encoded using 1 byte. They fall within the ASCII table of 0 to 255. You might think of the char map application. In the char map application, we can choose different letters, and it's an easy way to select letters that are beyond the typical keyboard letters. But if I type a capital S, I'm going to get this sequence of zeros and ones. And if I type a capital M, I'll get this sequence of zeros and ones, and every letter has a different sequence. These are each represented by 8 bits or 1 byte. So it takes 1 byte to store every character if we're working with English characters. If we're working with extended characters, which are those from ASCII 0 to 65536 as far as their decimal value, such as a Greek theta letter, it's going to take 16 bits or 16 zeros and ones, which is 2 bytes. And so it takes 2 bytes to store that character. Now, if we're working with international characters such as Chinese, those characters can take 4 bytes to store, and we have 1.1 million different possibilities of those zeros and ones. The way Python stores is based on what's the maximum number of bytes for any letter in that string, and then it sets all characters equal to that same byte size. So that way it can index values. Every character is the same number of bytes. So it could be if you've got a Chinese character mixed in with your English, the S will no longer take 1 byte to store, it'll take 4 bytes to store, so that every character is the same amount of bytes. Let me demonstrate that in a Python program that I wrote. The coding of this program is a bit more technical than I want to get into at the moment, but you'll see some of this in the future, such as importing other groups of methods or classes that we can use. And I import one here called sys and ctypes. It allowed me to go into the RAM and pull some information out. And then I have some methods here that I've created to do just that using those different classes. And so you can kind of ignore all that. What I want to focus on is this information down here. So what I'm going to do is I'm going to print or set a variable to a string and then show you some information about how that variable is stored, including how many bytes it takes to store, how many bytes it takes to store each letter. And you'll see here I've got a string of South Mountain and another one of ABC that allows us to draw some information from that. And then I did an Arabic character here that's going to take 2 bytes to store. And then some other information here we'll look at in a minute in terms of working with string methods. We're going to focus on these 3. In fact, what I'm going to do here, I think, is just comment this out so we don't see this run at the moment. I'm going to save this and let me run it. So what I want to focus here is these 3 strings: South Mountain, ABC, and our Arabic characters, just a single Arabic character. So South Mountain is 4 characters in length. If we count up the number of characters including the space, there's 14 there. In ABC there's 3, and in our single Arabic character there's 1. But let's look at how these are stored. So the total bytes to store South Mountain is 63 bytes. But it takes 1 byte per character. And you're thinking, okay, 1 byte per character should be 14 bytes, except there's a bunch of encoding information that has to be included in each string, and that varies from 49 to 80 characters based on the type of encoding being used, which would be the type of, or the number of bytes per character. So in this case, this is 49 encoding bytes that are required at the front end. And so it takes 14 bytes to store the characters. No difference here on ABC, except the total number of bytes is different because we only have 3 bytes to store the characters, plus that 49 gives us 52. But when we get down to the single Arabic character, it takes 76 bytes. And so that byte, or that character, takes 2 bytes to store, and there are now 74 bytes on the encoding information. So 74 plus 2 gives us 76 bytes total. So I just want you to be aware that the amount of storage being used per character does vary based on the characters that are being stored. Okay, so when I store South Mountain or assign that to the variable campus, in memory we're getting 49 bytes of encoding information and then 1 byte per character. And there are 14 characters in South Mountain. Each character can be assigned an index number, and we start counting with 0 for our index numbers. So S is index 0, the H is index 4, the capital M is index 6, the space is index 5. Remember, spaces are characters. They take up storage space, even though they may not take up space in your document as far as what appears. But we can assign, or we can look up each of these letters based on the index. So in object-oriented programming, we have methods, and methods always have a set of parentheses, and usually something inside that parentheses is going to work with, and it returns a value in most cases. So built into Python is the len, or length method, which takes a string inside of the parentheses and returns the number of characters of that string. So I can write a Python statement of numchars is equal to len campus, and then I can print numchars. In this case, it would print out a 14 because there are 14 characters. Now, even though we start with the index of 0, when we count the number of characters, we do start with 1. So there's 1 through 14 here, 14 characters. That's what gets printed out for the length. Now, we can think of our string as a list, or if coming from other languages, an array of characters, each one with an index number. And I can have a statement that says substring 1 equals campus, and then in square brackets I put a 0:5. Now the 0 here says I'm going to start with character 0 and I'm going to end with character 5, but I'm not going to include that character. So this last index is exclusive. So I'm basically going to take characters 0 through 4, which is south, and I'm going to assign that to a new variable, a string variable called substring 1. And then I can print that substring and I get the word south. So we can use this range of characters to extract something. Other languages you might have a substring method. Python uses ranges in terms of the indexes of the string characters. Here then is another example. I'm going to take the range from 3 to 5. Now again, that 5 is going to be exclusive, so it'll be characters 3 and 4 to be the th. And I'm assigning that to substring 2, and then printing substring 2, and I'd get the th. If I don't include a second number, so here I do 6 colon, it's going to start with the index 6 character and go to the end of the string. Doesn't matter how many characters there are, it just automatically reads to the very end. So in this case, the end is going to be the n in mountain. I'm going to assign that to substring 3 and print that, and so I get the word mountain. And finally, if I just put one index number with no colon, it's going to be a single character, and here it's just going to extract the index 6 of the m and assign that to substring 4, and I print that out. I just get the capital M. A string, whether it's a literal string or a string variable, is an instance of the string class. And the string class, like other classes, has methods. And those methods are accessed by taking the string and using a dot in the name of the method and passing any parameters or arguments in that method that we are required to use or want to use. So one of those methods that is part of the string class is the find method. And so here I'm going to take the campus string and access the find method by specifying campus.find, and in the parentheses I'm going to put a space, and that's a literal string of space, so it's inside quotes. What the find method returns is the index of where that phrase or character begins. So I might have searched for mountain and I would get a 6 in this case for campus. That mountain starts in the 6th index position. In this case, I have a variable called spacelock, and I'm looking for the space. And if I were to print then spacelock, it would print a 5. So it's index 5. It's going to be the 6th character, though. Here's another example. I'm going to look for the first T, and I'm simply going to find the letter T using the find method for campus and print that out. And it's going to print a 3. the location of the first T in south. I can add a second argument to the find method, and that is where I want to start searching. So I want to start with the location after that first T to find the next T. So second T in this case equals, and that should be an equal sign, not a minus sign, campus find T, comma 4. It's going to start looking in the 4th position and find the next T. Well, that next T is in index 10, and that's what gets printed out. If I search for something that doesn't exist in that string, the value that's returned will be a -1. Let's take a look at this in Python. Here's my Python program, and I'm going to go back a little bit what we discussed earlier in the video as far as the ranges. So I have campus equals South Mountain. I'm going to show the length of campus, how many characters there are, and then I got substrings 1, 2, 3, and 4, which are going to pull out those different ranges. From 0 to 5, we should get south. From 3 to 5, we should get TH. From 6 onward, we should get mountain, and just 6, we should get a capital M. I'm going to print those out as a list, and I'm going to separate those 4 items with a new line character. Then we're going to use that space lock equals campus.find. I'm looking for a space. I want to know the location of that space. I'm going to print that out, and then we'll do that first T that we just saw. I'm going to print out the location of the first T, and I'm going to search for another T starting with index 4. One thing you could do here, if you don't know where that first T is going to be, is you could do this as first T plus 1 is going to start with the character after that first T. And then I'm also going to look for lock H or location of H. I'm looking for an uppercase H. Now these finds are case sensitive, so if you want to take that case sensitivity out, you could use dot upper or dot lower and search for an uppercase or a lowercase. What I want to demonstrate here, though, when I look for an uppercase H, which does not exist in South Mountain, it's going to return a -1. We can use input from the user to do a search. So that's what I'm going to do here. I'm going to get the user to enter a string to search for. It could be a single character, it could be a word, it could be a phrase, it could be a group of characters. And then I'm going to take use the find method to search for that search variable in the string campus and return the location. Now if it doesn't find it, then that location is going to be a -1. And if it's not -1, we're going to say substring found starting at index, whatever the index number was. But if it is a -1, then we're going to hit the else fork and it'll print substring not found. Let me run this. So we see this first line of output. There are 14 characters in South Mountain. It used the len method of campus to return 14, and that's what's put into our print string. The range from 0 to 5 is south. The range from 3 to 5, remember that 5 is exclusive, so it's basically characters 3 and 4 is the TH. 6 onward is going to be the mountain, and just 6 is the M. Then we look for the location of our space, and our space is in location 5. That's the 6th character, so we start counting with 0. Then I looked for the first T. That's in location 3, index 3. Then I searched starting with the index 4 in this case. So the next character, I'm going to start searching, and we're going to find the next T is in index 10. Looked for the uppercase H. -1 doesn't exist. And then now we're asking to search or enter a string to search for. And if I type in NT, I'm told it started index 9. Remember, M was 6, 7, 8, 9 is the N. I'm going to run this again. And this time I'm going to search for SMCC, and I'm told the substring was not found. SMCC does not exist in South Mountain. We're going to use this in a couple future lessons in this unit. One is a project where we're going to parse out a name into a first and last name that the user enters. And then another project will be to replace a word in a string with another word. And to do both of those, we will use the find method.